Monday, the 23rd of November, only day of this class this week. So we just found slope before, but now we're going to learn how to do it by mathematically. Okay, we learned how to do it from a graphically. Now we're going to learn how to do it mathematically. So first of all, I'm going to write my name. Okay, me llamo Senor Castle.
I have a TikTok to show you later.
Alrighty. So the slope of a line can be found even without a graph, as long as you have two coordinate pairs. So the slope formula, m equals, we talked about it being rise over run before, right? We talked about m being rise over run. Does that sound familiar? Oh, I really hope so. Okay. So we also have this formula, y2 minus y1 over x2 minus x1. That might look a little familiar to you as well. Okay. Now another way sometimes you see it written is like this. It looks like, you might be like triangles. Why are we talking about triangles, okay? It's the Greek letter delta, okay? Delta y over delta x. Delta in math just means the change, okay? Right, Josh? Okay. Delta just means the change, okay? So it's saying the change in y over the change in x, okay? We talked about how it was the rise over the run. We're saying how far are the two y values apart? How far does this go up or down between 2 points? Over how far does it go left and right between 2 points? Over the run. So we're saying how much does it change, okay? So it doesn't matter which point you start with. Okay, did it matter when we were graphing between 2 points and we were finding the slope? Don't draw this, okay? But when we were finding the slope between 2 points, did it matter whether we started with this point or the one that was bottom to the left or the other way around? No. But what did matter was that if we are counting from the bottom left point up, we continue counting from the bottom left point to the right. So we couldn't count up and to the left, we had to go up and to the right. Okay, so we had to start from the same point and continue from the same point. So same idea. And we always reduce when possible. So we're going to have these 2 points, 4, 5 and 6, 14. Those are two coordinate pairs. And we're going to find the slope between these two. Well, a moment ago we said m is equal to y2 minus y1 over x2 minus x1. Now you might be wondering, y2, y1, x2, x1, are those exponents? Well, no, exponents are written where on a number? Where are exponents written on a number?
The top corner.
Yeah, the top right corner. But where are these written? Bottom right corner. Okay, this is what we call a subscript. Has anyone ever heard the prefix sub before? Maybe like submarine or subterranean. What's sub mean?
Under.
Means under or below, okay? So a subscript, script is just writing, okay? So it's written below everything else, okay? So it's a subscript. So we're just saying,
Substitute.
what?
Like the substitute is there below.
That's actually not usually what a substitute means. But maybe. I guess, I don't know if that's right from that or not.
Like they're below the teacher?
I don't know. Anyway, so the x1 and y1 and x2 and y2, those just talk about the points, okay? So each of these coordinates are an x and a y, right? Like this is an x and a y pairing up in the top left. So this is just x1 and y1, just because they're the first coordinates. Which would make the second coordinates 6, 14,
The snow sticky.
x2 and y2. It would just make them the second such coordinates, okay? So we have the first coordinates, we can call them x1, y1. The second coordinates, we can call them x2, y2, just because they're the second coordinates. That's all 1 and 2 means. It's just, oh, it's the second y, or it's just, oh, it's the first x. So what we're going to do is we're going to take this formula, y2 minus y1 over x2 minus x1, and we're just going to plug things in. So what did we say is our y2 of all of this? 14. So we're going to put 14 in the y2 spot. And on 14, we're going to do 14 minus what? 5, because that's what y1 is.
I know, 1, 2.
Over what?
6 minus 4.
Over 6 minus 4. So we have this fraction now we set up. Any questions on how we got this, okay? I really want you guys to understand how we got this. Any questions on how we got this? Haven. Okay? That's our setup. Okay? But is there some math we can do here? There totally is. Okay? We can subtract. What is 14 minus 5? It is 9. And what is 6 minus 4? 2. Now, we always like to reduce when we can, but can we reduce 9 over 2? No, so our slope is 9 over 2. Does that look like a slope we might have gotten before as well? Yeah. Good. Okay. Now, we also could do, okay, I'm going to do this in a different color to show you guys it's an also thing. You don't have to do it. What if we went the other way around? Instead of doing y2 minus y1, what if I did y1 minus y2? I switched around. I did 5 minus 14. Okay? It's going to be a negative 9, won't it? But let's say I also switch the bottom around. I put 4 minus 6 instead of 6 minus 4. What's a... not quite, because they're not reciprocals. What's a negative divided by a negative, Abby? You said it a moment ago.
A positive.
Positive. So do I still get the same slope?
Yes.
Yeah. So did it matter whether I put the 14 or the 5 first? No. Did it matter whether I put the 6 or the 4 first? No. But let's look at this other example. Let's say I put the 14 first again on the top, like I did originally. But on the bottom, let's say I put the 4 first. I'm going to have positive 9 over negative 2. Is that the same thing as my other answers? No, so clearly something's different here, right? Okay, well, if we look here before, when I had my second y going first, which of the x's came first? The second one. Well, okay, well in the next example, when I had the first y come first, which of the x's came first? The first one. But here in the orange one, the one that's different, when I had my second y come first, which x did I have come first? The first one. Wait, that doesn't match up, does it? Okay, so that's the important thing with slope, okay? That's the important thing with slope, is you can't mix up the x's and y's, okay? So whichever one you put first, you have to put the matching x or y first. So if I put 14 first, I have to put 5 first because they're both the second ones. If I put 14 first, I have to put 6 first because they're both the second ones. And if I put 5 first, I have to put 4 first because they're both the first ones. It doesn't matter which one you do, though. Let's try example 2. So example 2, we're rocking with negative 3, 6 and 5, negative 8. Does someone want to try to help me set this one up? Okay, Courtney, go ahead.
Okay, so it's 8 minus 6.
Okay, I think it's a negative 8 minus 6, but yep.
Oh, okay. And then it is 5 minus negative 3, but you can make that plus.
Yeah, very good. So I'll stop there for a second and then do exactly what you said, okay? So negative 8 minus 6. So Courtney put the negative 8 first, okay? And so did Courtney have to put negative 8 first? No, but because she did, what did she have to put first in the bottom? The second one, the 5, that go with it. And then she did minus negative 3. Courtney did a really good job of making sure she kept track of all of her negatives, okay? She's subtracting a negative 3. Now, Courtney said a second ago that when you have two of those subtraction signs, two negatives in a row, what's that become? Positive. So we really have 5 plus a positive 3. Now, what is negative 8 minus 6? Negative 14. And what's 5 plus 8? Or 5 plus 3 is? 8, as I say the answer. Okay, and negative 14 over 8, does that reduce?
Negative 7 over 4.
Okay, negative 7 over 4. Now, does it matter whether the negative is on top or on bottom or out in front? No. It super does not. And that's our answer. And once again, if you had flipped it around, you had done the 6 first and the negative 3 first, that you'd get the same exact thing. You'd see the negative on the bottom, but it's the same answer. I told you it's short. Okay. Any questions on this one?
I understand.
Good. I want you guys to try number 3. Okay, when you have number 3 or have questions, go ahead and raise your hand. So, on this one, does anyone want to volunteer to help me set this one up? A couple different ways we could. Okay. Abby Dasher.
2 minus 0
Okay.
over negative 5 minus negative 1.
Very good. 2 minus 0 over negative 5 minus negative 1. Now, did we have to put the 2 first on the top? No, did anyone do it putting the 0 first on the top? Okay, just curious. Now, 2 minus 0 is 2. Now, what happens with a negative 5 minus a negative 1? Yeah, it becomes adding a 1, adding a positive 1. Now, negative 5 plus 1 is? Negative 4. And are we done yet? Have to reduce. Becoming a 1 over a negative 2. Does it matter whether the negative's on the top or bottom or out in front? It super does not. Okay. Questions on that one? Alrighty, okay. I want you guys to go ahead and try numbers 4, 5, and 6. Okay, when you have numbers 4, 5, and 6 or have questions, raise your hand. Talk about these up here. So on the first one, we can do this one of two different ways. You can either do negative 3 minus 7 or 7 minus negative 3. Either way is fine. So I'm going to do 7 minus a negative 3, which turns into addition, and then negative 3 minus 10. That gives me 10 over a negative 13. Does it matter whether the negative's on the top or the bottom, though? No, so as long as you have 10 over 13 and there's a negative on there, but just one negative, you are Gucci.
Gucci gang.
Number 5. M is equal to, well, top at 6 minus 6, no matter which way you go. And so bottom, we could do 5 minus negative 11, or vice versa. Turns into adding. 6 minus 6 is 0 over 16. What is 0 divided by literally anything? 0. There's anything except for 0. If you have 0 pizzas for 5 people, everyone gets 0 pizza and everyone's sad.
I have a question.
Yes.
So for number 4, I probably just did something wrong, but you got positive 10 up top, and there really could have been negative.
Yeah, definitely. So you could have done negative 10 over positive 13. Is that what you have?
Yeah.
Yeah, so you just put the other number than I did. You put, see on the top you had negative 3 minus 7. And then on the bottom you had 10 minus a negative 3, which turns into a positive 3. Yeah. And that's perfectly fine. Both of the ways we did it are great. Great question. Okay, let's look at number 6 here, okay? M is equal to, once again, you can pick your order. I'm going to pick try and make the top one positive as often as I can, okay? So would I rather do 7 minus negative 3 or negative 3 minus 7 is the question I ask myself. And then I'm like, oh, I'd rather subtract the negative because that's going to turn into a positive. And on the bottom, 14 minus negative 2, same thing, turns into a positive. And I get positive 10 over positive 16, which reduces to 5 over 8. Now, if you had put the other numbers first, if you had put those two negative numbers first, then you would get a negative 10 over negative 16, which also becomes a positive because a negative divided by a negative is a positive. Questions on that? Okay, give me a thumbs up if you're feeling good about this, thumbs down if you're not. Thumbs up if you're feeling good about it, thumbs down if you're not. Okay. We're going to see more examples of these as we continue on, okay?
Why is the snow so big?
I don't know. So, rate of change, okay? Slope is this idea of rate of change. So, rate of change is a ratio that describes, on average, how much one quantity changes with respect to another quantity. So it's how much one changes with respect to another quantity. So how much one thing compares to another changes. If x is the independent variable, have you guys heard this in science before? Okay, x is the independent variable, meaning it's not the one that changes, okay? Or it doesn't depend on something else. And y is the dependent variable, meaning it depends on x. So whatever the y is would depend on whatever the x was. Then the rate of change would be the change in y versus over the change in x. Is that the same thing we wrote for slope a bit ago? Yeah, we wrote this for slope a bit ago. Okay, it's basically slope. Rate of change is slope.
What's the triangle supposed to represent?
It means change. So you can put over here, maybe over to the side. Triangle means change. Okay? It might be a good idea to write that down so when you're looking at this later, like, what did triangle mean? I know he said it, but what did it mean? Okay, it means change. So, use the table to find the rate of change and explain the meaning of the rate of change. So here we have the time walking in seconds, so someone walking, and they have the distance in feet that they walked. So they're saying when you walked 1 second, a person walked 5 feet. When a person walked for 2 seconds, they walked 10 feet. When a person walked for 3 seconds, they walked 15. And 4 seconds, they walked 20 feet. So we can find the average rate of change for time walking and distance walked.
Is that no one like fast walking?
Ratio is 1 to 5.
I don't know. What is that?
What is the ratio be 1 to 5 then?
Okay, for every 1 second you walk 5 feet.
Yeah.
Okay. Yeah, that could be one way you can put it. Okay. Now we can pick any two values. Okay. We can pick any two values to go between and say, well, how much is the difference between each of these y values?
5.
Okay, they're each 5 apart, aren't they? Okay, you can say they're each 5 apart. Okay, we are adding 5 each time, right? And how much are the x's increasing by every time?
1.
Okay, they're each increasing by 1 every time. So if we were to do the y over the x, okay, time doesn't depend on how far you walk, but how far you walk depends on how long you're walking. Okay, so if we're doing the change in y over the change in x, how much are the y's changing right now? 5 feet. Over, how much are the x's changing right now? 1 second. So our rate of change is 5 feet per second. So that means every how could we word this in a couple different ways? I'll have you guys word this. How could we word it?
Every 1 second walk.
Every 1 second, 5 feet.
Okay.
Every 5 feet we walk.
Okay, so you could word it 2 ways, okay? So I heard both 2 different ways we could word it, okay? For every 1 second. For every 1 second, you walk 5 feet. And then another way I heard it said, so I'll write it in a different color, was you walk 5 feet every second. Are those saying the same exact thing? Yeah, they're just saying it in different ways. But they're both saying the same exact thing. Okay? Questions on that? Okay. Is this something that you guys have seen in science quite a bit there? Okay.
I failed the test over it.
Oh, that's not good.
I failed the test over it.
Yeah. Hey guys. What's the problem on these notes? Kind of dope. Okay. In the year 2000, population of Gretna was about 2,300. Okay, 2,300 people. And in 2010, population was about 4,400. So we're trying to figure out what is the rate of change during this time. What is the rate of change during this time? So which one of these? What are our 2 variables? What are our 2 variables? Courtney? Okay, the year and the population. So we have year and we have population are our 2 variables. Okay? We have our year and our population. We can make a table out of this like in science, right? So in the year 2000, the population was 2,300. In the year 2010, the population was 4,400. Is this a table you guys have similar to what you guys have done before? Okay, probably. Which one of these is the independent variable? Which one doesn't depend on the other one? The year, right? The year doesn't change based upon how many people you have in a town. It's not like if a town gets bigger or smaller, we change what year it is. But the population can depend on the year, okay? Because, what happened in this year, how much time has passed, can end up changing the population. So our year is our x value, our independent variable, and our population is our y value, our dependent variable. So how would we find the rate of change during this time? Okay? Courtney, go ahead.
So you look at how much the year went up.
Okay.
What you're given, which is 10 years.
Okay, went up 10 years.
And then the population went up 2,100.
Okay.
So you could say for every 10 years, the population grows 2,100.
Okay. So you could say for every 10 years, the population grew by 2,100. Okay. Now, could we find what the average was per 1 year using this?
You could divide by 10.
Yeah, you could take it as a fraction, okay, like slope is. Okay, we could take the change in y, 2,100. Let me change colors for this to show it's different. You take 2,100 divided by 10. The change in y over the change in x. 2,100 people divided by 10 years. Well, is dividing by 10 easier or hard than other numbers? Usually easier, yeah.
Is this actually true? Is like Gretna that small?
It was.
Really?
It's grown a lot since then.
I'm gonna say like third class A school.
Yeah, like right now they're huge, aren't they? Gretna's gotten huge, okay? Because Gretna's grown a ton. Yeah, I'd actually be really curious to see what it comes out to be for the 2020 census, what their population is, because it's grown a ton since then. So 2100 divided by 10. What happens when you divide by 10? Yeah, you just take off a 0 basically, right? You're going to slash away a 0. So 210 people for every 1 year. So could we say something for that as well, as a different sentence? Haven, what's a sentence we could say for that one?
For every 1 year, 210 people. Population grew 210 people.
Okay, for every year, the population grew by 210 people. Now, is that the only way you can word it? Certainly not. You can word it lots of different ways. You could say 210 people move to the town every year on average. Okay, you could say something like that. Question on this at all?